All right. So I pulled this September of last year. Got some wonderful graphs, which I love.
Oh, yay.
Oh, yay. No, this is not algebraic graphs, statistical graphs. So, headline. Percentage of Americans lacking health coverage falls again. Why do we care?
Because we're Americans.
Oh, we might care because, good, we might care because of that. Because this is tied, if you think of it, it's tied pretty closely to Obamacare. That's kind of the point. That you now have millions and millions. I've heard the phrase millions. I haven't checked the data on this yet. Millions of people that were not able to get insurance before now have it. And that's kind of crazy to think about. When the country only has 300 million people in it, and now all of a sudden millions more have insurance, that's like when I was told that 1 billion people watched the World Cup final in 2006.
Wow.
Like that floored me. World Cup soccer. Those of you Americans in the room, it's a soccer match. Fairly important one. 1 billion people. Let that just wash over you for a moment. That's one person out of every 7 on the planet were watching the same sporting event. So just let that wash over you for a second, and it makes you wonder why they call it the Super Bowl. It's like whatever. So what's that? So, but the scale of numbers sometimes gets lost on us. Politicians, we spent $1.5 million. How much more do we have to spend? I don't know. The government spends that much in like 30 seconds. So spend more. Like a million versus a billion versus a trillion. It really is not. Oh, excuse me. I think I used the wrong number earlier with the healthcare. But nonetheless, paying attention to the orders of scale of when these numbers come at you. So when I hear, let's see what this says. For the second year in a row, the proportion of Americans without health insurance declined, even though real household income and the poverty rate were not significantly different. I don't want to get too far into those numbers right now. I want to focus more on the health insurance part of that. That's what I really care about right now. And I want to see if we can use past data to make future predictions. That's kind of, I gave you guys a bunch of programs last time. One of them is a predictor program based off this kind of thing, and I know I had to fix the program for some of you, and I did. So when we take our 5, I'll reshare that program and with the updated version. What I did was I went ahead and collected some data. It's fairly old now, but we're gonna see if it extends into the future. Here's the year. Of record. And then that's the number of uninsured in 35 million, 38 million. It's of course not exact. It's a predicted number based on, I believe this was Census Bureau data. So but the first thing I want to do to make the math a little bit easier, make it digest a little better, is I want to reshuffle around. You don't have to do this, but I have a little document that I've created for you guys that'll be easier to deal with if you have the numbers looking the same. So what I did was I changed 1992 to 2, 94 to 4, 96 to 6, and so forth and so on. Just to make the number smaller, it makes the equation more manageable that we're about to deal with. And also I knocked down the uninsured, since they're all in millions. I just knocked the zeros off and called it 35. Now, realize it's not 35 people, it's 35 million people. But as long as you indicate that somewhere carefully in the data set itself, the reader and you and or both will understand what you're looking at. So what I want to say is, I want to say, okay, this seems to counteract the claim over here. Seems to, maybe. Over here it said, uninsured rates are going down. That says number of uninsured is going up. So how could both of those be true? Give me 1 or 2 reasons as to why both of those can coexist happily. Michael?
Well, one is a percentage number and the other is actual.
One is a percentage, one is actual. Dina, I tortured you with a data set back in 244 where Governor Jeb Bush freaked out in the year 2000, I believe it was, because the number of motorcycle deaths had skyrocketed, to use his word. Florida used to have a mandatory helmet law. No, it was 09 to 010. They had a mandatory helmet law for motorcycles. Right. And they revoked it. They said, you know what? You don't wear a helmet, don't wear a helmet. Your head, your choice. Your head, your choice. I didn't start this, did I? Oh, I did. It's recording. We're good. I didn't see my nose either. So, what happened in the year 2000, they had data from 2000, and there was something like 140 deaths in 2000, or something like that. Something awful. I'm not saying a death is to be ignored. But in 2010, the year after they revoked the law, it was something like 438 deaths or something. And he's like, you see that? 4 times as many deaths in 2010 as in 2000. We gotta bring the law back. Put your helmets back on. All you gotta do is go look at the data. Sure, the number of deaths went up, but guess what went down? The percentage of death. Because what also went up from 2000 to 2010? The number of people on the road riding motorcycles. And the rate of that increased faster than the rate of death, which meant the overriding percentage actually went down. You see what I'm getting at, friends? That was the fallacy in the argument. So I'm not calling this a fallacy argument. I'm saying that this is, I'm making up words here. These can coexist. A percentage can go down while numbers are going up. All that implies is what? There's more people in the sample that we're drawing from. And that number is growing faster than the rate of uninsuredness. So that's why it can coexist. It can also coexist happily because this article was written in 2013. The latest date on here was 2000. There's a decade of gap right there, and things may have changed between 2010 and 2013. Pay attention to those kinds of details because they can be important. Okay, so we got that data so far. So what I'm going to do is, here's your data table from the previous screen. That's what's called a scatter plot down here. It's a scatter plot. Now, what is a scatter plot? Can anybody tell? Can anybody kind of figure out what that graph right there is showing you? Can you kill the second? Tell me your name one more time.
Tawny.
Tony, thank you. You might kill that. Perfect. Thank you. What is that scatter? I'm going to zoom in on it.
It's showing the numbers.
Which numbers, Frankie?
Well, in year 2000, or the 2 is 35, so
Oh,
those are all
good.
2. Yeah.
Good, good, good.
It shows the data of the graph.
So you see this guy right here? That point has how many coordinates? It's got 2 coordinates. It's got an X and it's got a Y. And what I've put down here on the X-axis is the number of years since 1990. So 92, 94, 96. And here I've got millions of people. It starts at 33. Technically speaking, it should start at 0, but 0 seemed too far away. So 35 is paired with the 2 because in 1992 there were 35 million people. And so forth and so on. Every one of these points, every one of those points is paired with one of, exactly, represents one of the points up there. Why would we care to look at this image in this way? Why would we care to look at this data with this image?
It's visually.
Tell me your name.
Jeremiah.
Jeremiah. What did you say? Did you say?
Shows direction.
Oh, in what way? Thank you, Jeremiah.
An increase of every.
I like that very much. I don't think I did this. Hang on one second. I didn't. Let me pull this. Let me make a new slide real quick. Thank you, Jeremiah, for that. Make a new slide. Let's drop that image right in here so it's bigger. And then what I'm going to do is I'm going to pull this up. Now, Jeremiah, what he just said was it shows direction. It shows direction of the growth. How many of you noticed from the data table that the people without health insurance numbers were going up? We noticed that, right? Did you notice how fast they were going up from the data table? That might not have been as obvious, right? Let's back up to the data table real quick. Okay. From 1992 to 1994, they went up by 3 million, yeah? From 94 to 96, 1 million. From 96 to 98, 2. And from 98 to 2000, 3. Now, I don't know how many of us actually looked at those numbers in that way when that went by the first time. But it becomes more obvious, whoops, when you see this guy right here. You're like, oh, it's almost predictable how they're going up. It's almost predictable how they're going up. It seems like we can continue the pattern. The question I have is, what pattern should continue? Now, you may have done this in Math 95. Some of you may have done it in Math 60. It depends on who you had. But there is something called modeling in mathematics. Like modeling. But it's different in mathematics. In mathematics, it's mathematical modeling. And what that means is fitting equations to data. Where's the blue one? We'll use green. So what I want to look at today, start looking at today, is what's called mathematical modeling. Mathematical modeling. So what I want to do is, I want to figure out if what Jeremiah just said is beautiful, by the way, my friend. Thank you for that. His point was that there appears to be a predictable pattern in the data. In other words, as years go on, what happens?
The number of uninsured increases.
Increases. I love that. Let's throw some old terms out from back in the day. Back in the day, algebra back in the day. What do we call the x variable usually? Do you remember? What kind of variable? I might be, somebody, I think it's like, Jacob?
Independent.
The independent variable. Let's refresh our memories. We're going to call this guy it's terrible. We're going to call this guy down here, purple. Shiny squirrels. The independent variable. Why? How come?
Because the years are going to continue to go up no matter what.
I love that, Michael. The years, time marches on. Basically, time is a very good independent variable because nothing really governs time. It just goes. I mean, you start at 0, whatever 0 was, depending on what you believe, and it just goes. And it's metric. I mean, time passes in a fairly, depending on how fast you're going, it passes in a fairly consistent manner. What do we call this guy over here?
Dependent.
That's your dependent variable. Thank you, Chelsea. That's your dependent variable. And why is that?
Dependent on the years.
Good! Not just, I like that, Kelly. Thank you very much. It's dependent on at least the years, if not even something else. Because there are lots of things going on besides the passage of time that's influencing the number of uninsured people per million in the United States. For example, one other variable might be
The population.
good! The population is changing as time is changing. Thank you, Chelsea. Yes, as the population goes up. Remember what they said, the rate is going down. But if the population is going up, depending on how fast the rate is dropping, the number might actually be going. Hence, Governor Bush and the helmet law. Same exact thing. Good, thank you. Population is going. What else could possibly affect it?
Economy?
The economy could affect it. Sure, if insurance gets too prohibitively expensive, you're gonna sacrifice health insurance and say, just fingers crossed we don't get hurt. Exactly. I remember the first month I was here at COCC, I was some kind of a lapse in my health insurance because I forgot to file some piece of paper in Delaware. So the first month, September of 2003, 2004, they're like, you don't have health insurance right now. I'm like, crap, I'm a rock climber, I'm a mountain climber, I'm a mountain biker, I'm like, just sit in my house on the couch. Don't go outside. But that's the thing, I mean, at that point I was terrified. So there are other variables, but this variable is dependent on things, whereas time really isn't dependent on anything. Now you can argue, if it depends on how much you like Einstein and his theory, that time is dependent on certain things, but don't worry about that here. We're not moving fast enough to worry about that. Beautiful, beautiful. So now that we've got, let's take 5. Before we get into the nuts and bolts of this, it's 11 o'clock. Let's take our 5, and then we'll come back and do it. I kick you guys out, stop the film.